a web server programming series. So last night I started work on this a component called WebSockets, and this is implementing an RFC, an internet standard, for two-way communication between web servers and clients. And it got pretty far. It can do almost everything. We just need to complete some of the loose ends and some of the things that required some support libraries. So the first one is, in order to do the open handshake, we need to implement a couple different, I was going to say hashing algorithms, but I don't know if base64 is, no, if base64 is not a hash, it's an encoding. So we need an encoding algorithm called base64, and we need a hash function called secure hash algorithm 1, or SHA-1. I already had SHA-1 implemented previously, so I pulled it in. I just don't have any unit tests, so I want to write some unit tests. And I found a nifty set of test vectors we can try. I don't have anything for base64, so we're going to start that one from scratch. And then for the, what is it called, anti-cache poisoning mask that's applied to all client messages from this WebSocket, we're supposed to use a strong source of entropy for coming up with the mask bytes. So we're going to do exactly that, find a strong entropy random number generator. I found two that pretty much cover all the OSs I want to support. So in Windows, there's the bcrypt genrandom, and for Unix like OSs like Linux and Mac OS, there's /dev/urandom. So with all of those pieces, I should be able to implement the open handshake functions of WebSocket. And then if I have time, I'll start work on the demonstration for WebSockets, which is going to be a chat room. It'll be a plugin to our web server. And I'll need a web app, which is where I'm going to deviate from C++, which is what I've been using exclusively the last 30 streams. I'm going to move to the React framework from Facebook to try making a web app to test our chat room. That's going to be interesting because I'm not very good at React. I've done a little bit of the tutorials, and I've already started forgetting stuff because I'm not using it every day. So that'll be your opportunity, if you're watching, to make fun of how little I know about React. So I'll give you an overview. Of the WebSockets. So WebSockets library just has one class called WebSocket. A WebSocket can be in one of two roles, client or server, and the only difference is really whether or not you have to mask any messages you sent with the XOR mask to prevent cache poisoning. The client has to mask what it sends, and the server has to requires everything it receives to be masked. So we've defined some function types that the user of this class uses to get callbacks. One is it'll receive a string for any kind of message it receives, and a close code and reason if the WebSocket is closed. So we haven't implemented this completely, but presumably there's an open handshake. Once the open handshake is done, you call open. This will probably change because we'll be giving the connection to the open handshake stuff. And yeah, as well. So this is going to change. So right now we're assuming that WebSocket's already open. We give it HTTP connection, which is its connection to the outside world, and then role, which is whether it's a client or a server. And then at any time you can close. There's a default reason, which is no reason provided, but you can override it with your own code and reason. There is built-in ping, and the opposite of that is pong. Ping pong. That's like keep alive, like ICMP for TCP/IP. It's so you can send it in the background and make sure that the WebSocket is still connected. Then there's what you'd expect, sending text or binary messages. And you can choose to fragment them by setting last fragment to false, and that starts a fragmented message. And you just make sure the last one is marked true. And then here are the setting of the delegates for basically callbacks. Whenever I say delegate, I mean callback. So you can get called back for if the WebSocket closes, if you get a ping, if you get a pong, if you get a text message or a binary message. And then I'm using the pimple pattern, pointer to implementation, to kind of hide the actual private properties of the class. But we could peek inside here and look at the implementation. So there are a bunch of constants that are used to, let's see, how's the best way to describe this? If I go back to the RFC for WebSocket, like a lot of different protocols, they give a little block diagram. Maybe that's not the right word, but a diagram showing what are the elements of every message. So things like this fin bit, this mask bit, and this opcode, I have constants to declare to show where they are in the byte structure. So fin and mask are the high order bit of the first 2 bytes. And then here are the different opcodes. So if it's a part of a fragmented message, it's a continuation. If it's the beginning of a text or binary message, and the control messages are close, ping, and pong. Control messages have a maximum length. And then while we're in the middle of either sending or receiving a fragmented message, we'll record that fact with these enumerated types. Here are the private properties of a WebSocket. So it holds on to a connection to the remote side of the socket. It remembers what role it is. It remembers if it's sent a close frame or received one. And it remembers whether it's sending and receiving a fragmented message. And here are the delegates or the callbacks. If any of these events happen, we call these functions. We have 2 reassembly buffers. There's one for when we are still receiving bytes and we haven't received a full frame yet. And then we have another one for if we're receiving fragments of a message. We hold on to all the fragments until we have the full message. And actually that reminds me, one of the loose ends is we need to, for text messages, verify text is a valid UTF-8 encoding. And also for close reasons, same thing. And I don't know if we'll do this or not. Actually, I guess we should. I should have put this on the plan. Catch all protocol violations. So these would be protocol violations if the text in the text message or close reason is not valid UTF-8. I thought about that when I saw this message reassembly buffer. One reason to reassemble fragments first is you could have 2 fragments that are cutting apart one UTF-8 Unicode code point encoding. And so if you were to deliver each fragment individually, you'd have invalid codings at the boundary. But if you reassemble it first, you can recover a valid encoding. So I thought it made sense to deliver messages whole. Okay, so here are the methods that are internal. So we have an internal method used to send any kind of frame, and this does the actual encoding of the protocol. So setting the fin bit, determining what the mask should be, encoding the length. And then here's where we're going to be working on today, because right now I'm just picking a fixed constant for our masking key. The standard says we're supposed to pick a random one from a strong source of entropy. In other words, so that it's not predictable, so that we can't fall prey to like replay attacks and that kind of thing. And then we have another function that's similar for when we receive a frame in order to kind of figure out what we should do with it. So it's doing the reverse of send frame. It's making sure all the bits are what they should be, recovering the opcode, and then doing something depending on what opcode it's received and what state we're in. So it does the reassembly of fragments, it handles close, it handles pings and pongs, that kind of thing. We have a bunch of to-dos for where I noted that if we get there, it's a protocol violation, so we'll be filling in the right thing to do there. Here's the internal method for when we receive bytes from the connection. We put them in the frame reassembly buffer, and then we loop, and as long as we have enough to reconstruct a frame, we'll reconstruct one, which is here, receive frame, and then remove it from the reassembly buffer. And then here are the public methods. Here's open, open, close, and all that. They do what you expect, like ping and pong and send text. They all end up calling send frame, just with different opcodes. And then setting the delegates is extremely easy. We just remember what they are so that we can call them later. So let's get to work on bringing in the hash algorithm and base64, and then we'll be using those for open handshake. And we'll do system abstractions strong entropy random number for the masks. So I pulled in SHA-1 earlier. I made this a couple of years ago for another project. It's pretty simple. It's just really just one function, but I have two versions of it, one that takes a string and one that takes a vector of bytes. And it computes the hash of the data and returns it as a string. The implementation's basically, I took the pseudocode from the Wikipedia page on SHA-1 and I wrote it in C++. So this is pretty much what the Wikipedia page says you do to implement the algorithm. So it's not optimized, but it's sufficient for our needs. We're not going to be hashing huge things right now. The problem is we don't have any tests for it. So we're going to pull in some tests from this site that I found. Test vectors for SHA-1. So for example, they say if the input message is ABC, you should get this hash code out. So we can immediately start doing that. So what are we going to name our test though? Hash test vectors. I guess we only really need one test, right? And let's make a note. These test vectors, I'll put it inside. These test vectors were taken from, and then I'll refer to this site. It's always nice to give people credit for what they've done for you. And I just noticed I'm in Visual Studio Code. I should go to Visual Studio proper. Tests, SHA-1, hold on. SHA-1 tests. There we go. So I think what we'll do is we'll have a bunch of test vectors. So const vector of test vector. I'm trying to think, should I use a different word here? They call each of these a vector. Standard vector means something else, so we're using the word vector two different ways here, which might be a little confusing. I'm not going to worry about it too much. We're going to make a small little private class called test vector where we're going to put in the input and the output. We're using string. I need to put that in order, by the way. String is from string. And we already have vector. So ABC, they tell us, is hashed to this code. Oh, let me do a copy and a paste. All right. So that's what we expect to get out of the hashing function. And the next one will be the empty string. Gives us this hash code. Okay, and then this one is specially crafted to be like a boundary condition. 448 bits is one of the boundary conditions of the algorithm. Same thing with the next one, I think. You can see how much thought they put into their content. A lot of thought went into those characters, right? Okay, this one is another boundary. And as you can tell, they get longer and longer. Next one is 1 million repetitions of the character A. So we can say standard string, and there's a way to do a character and a count, right? Yeah, count 1 million of the character A. I should hash to this. And there's actually one more test vector. I don't know if I want it because it's sort of absurd. It's an extremely long message, which is 16 million repetitions of the of a lot of the alphabet. Well, kind of jumbled around. Crafted to be a gigabyte. I'm kind of hesitant to put it in because I think it'll just slow our tests down. Let's leave that out for now. So we'll say for const auto test vector and test vectors. And we make no, actually it's not a class, it's a function, so we just call it test vector input. And then we'll just assert or expect equal the test vector output. Like that. So let's see if that works. SHA-1 test debug SHA-1 test. Alright. Now just for curiosity, I wonder how long it takes to run our insanely long test vector. So that's this message repeated. Actually, let's make that a different test. This, again, we'll say this test vector was taken from. So we'll start with our base string, which is this guy, and then it's repeated this number of times. So standard string, actually let's use O string stream. O string stream builder. So say for size ti. I make a habit of whenever I use something from standard library, the moment I start using it, I add its include to the top. I is less than that number, which you need to get rid of the commas. Plus was I builder base string. Okay, so we're going to expect that when we hash it, we get this hash code. Oops. Oh, my thumb is getting sore. I have to stop using my thumb for the control key. So it would be SHA-1 builder.string, right? Oh, I need to give that a new name. Hash insanely long input. Yeah, this will probably take a while. While I wait for it to hash that, let me take a drink. Okay, maybe it wasn't such a good idea to run this in unoptimized mode. Okay, so it took 21 seconds. Out of curiosity, let me see what happens if I run an optimized build. So I switched Visual Studio to release. And I'm just going to tell it to build SHA-1 tests and its dependencies. And we'll run test release SHA-1 tests. So unoptimized took 21.8 seconds. Okay, optimized took 6.3 seconds. Here's where if we really wanted to optimize it, we would look up and see, or actually try to hash it with something like OpenSSL, or look up and see how long it should take, and then go from there. But not really. that much into this algorithm or optimizing it. So what I'll do, let's enable the user, if they want to enable this test. So this is how you do it in CMake. Go to the test right here, and you make an option. You'd say option SHA-1 test insanely long test vector. And you'll say include insanely long test vector. Takes 20 plus seconds unoptimized. And then we'll default it to off. And then here we'll say if that then target compile defines, I think it's called, this private include insanely long test vector. Okay. Then in the code, we can just say if def insanely long test vector. So you CMake dot. It will build it. It'll be not defined, right? And so when we run the test vectors, it's not defined. But if I do CMake, well, I'll show you how to do it with the normal text editor. So in your build folder, you'll have a file called CMake cache, and you just find where that option is defined now, and you just turn it to on, right? Run CMake again. Oh, I guess I misspelled that. That would work if I didn't misspell it, so let me go and fix it. I need to look that up in the manual, actually. I use velocity on Windows. On Mac, I use dash. It's an offline manual thing. Unfortunately, it tells me my CMake is broken. Yeah, so I'm gonna have to kind of look through it the old-fashioned way. It's in here somewhere. Commands, I think. Target compile definitions. Okay, that's close. Definitions. CMake dot. So now when we go back to Visual Studio, we'll see that when we reload the solution, now it's compiled in. So there we go. There's an example of how you can control whether or not something's included through a CMake option. And that's going to take 20 seconds, isn't it? So let's go turn that option back off in the CMake, Visual Studio Code, CMake cache. Go back and turn it off. Actually, I'll show you with a more user-friendly way how to turn it off. So I don't care about that test. So if you do CMake GUI dot, it shows you sort of a nice GUI version of the cache. And then you can, if I can make that resize, you can just look for that flag in here. How come I don't see it? Should be in here. Oh, here it is. SHA-1 test insanely long test vector, right? So they make it into a checkbox. So then you would hit configure and then generate. It's the same thing as running CMake dot when you do that. So now it's no longer compiled in. I actually kind of like how Visual Studio Code now still does the syntax highlighting, but it kind of dims it so you know it's not defined. I like that. So there we have the ability, if the user wants to run this long gigabyte test vector, but we don't require it. Well, we have it defaulted to off in the CMake right here, with our warning that it takes a long time. So let's check this in and we'll move on. SHA-1 get GUI. Right, add actual test vectors. Make the 1 GB test vector optional. Okay, next up. Base64. Okay, this is going to be a little fun side project. Another example, I can show you how to set up something from scratch using TDD. So, first we'll make the directory. By the way, if you want to get a copy of this code to follow along, there's a link below to where you can find the top level Git repository in GitHub. Once you get that Git repository, there's this main.xml file, and it lists all the other repositories you need and where they need to go in the path. And I made a tool to help with that. It's called Nugget. So if I do Nugget select main and then Nugget pull, it will pull all the sub-repositories. For me, I already have them, so it doesn't do anything. But for you, it would clone them all. And then you have a same copy of everything that what I have now. And another thing you can do with this is you can do status. If you do A, it'll show a line even if there's no changes. Without the A, it doesn't. But this kind of gives you a list of what you have, and then if anything's different upstream, like this exclamation mark here means there's more from Google for Google test. And this hat means I've pinned it, so I'm not going to take the tip of the branch. I'm using a version that I've tested. And if there's stuff over here on the right, it would mean that you have changes locally, or there's changes upstream. Oh, sorry, changes locally that you've either committed or haven't committed yet. Okay, so let's make that directory. Not here. This shell, make directory base64. And then we'll make it a git in repository. And then I will remote add origin git at github.com, then my name, base64.git. And now it should show up here in Visual Studio Code. Right there, base64. I'm just going to copy the structure of what's in SHA-1 here. Whoa. We'll copy it and paste it in base64 and change things up. I definitely recommend doing this if you have like a common boilerplate or common style or layout for projects. Like I have everything under an MIT license, so I just copy paste my license everywhere. And then README, I have sort of like the way I build things, and it's pretty much the same for all projects, so I don't have to keep typing it every time. I'll just copy from one project to another and just do a bunch of renaming. And this is a library which implements the base64 encoding algorithm. And that's described, I had that in my notebook, 4648. And I had that in my web browser too. The base... Oh, I actually thought I put the name in here. Oh, maybe I should just say that. Copy, paste. How come this copy is not working? Copy that, please. Copy, paste. Okay, base64 functions are used to... Actually, we're going to make it a class. Or do we? Do we need to make it a class? Let's just make them functions. Base64 functions are used to encode and decode data using the base64 algorithm. Okay, make lists. Replace SHA-1 with base64. I'm wondering if I should make the library name something that would fit base 16 and 32 if we ever do those. I don't know. I've never actually used base 16 and base 32, so How about we'll save it until we actually need to do that. Can always rename things later. So right now the library itself would also be called base64. And whenever you have a library and a class or function that's the same name as the library, it's called a principal class or function. Oh, how did we get a source.1 there? That shouldn't be there. Did I accidentally check that in? I did accidentally. That's an accident. I wonder if I accidentally committed that into SHA-1. No? Okay. That's interesting. It was there, but it... Okay. Let me look at the history. Tree. Okay. Source. Yeah, alright. I must have slipped when I was copying and pasting. Do I have the same thing under include? No. Alright, whatever. Back to normal. Nothing to see here. So this was renamed base64 tests. Source is base64. Include is base64. I should describe sort of my standard layout here. So at the top level, I'd like to have a README and a license, and I use CMake, so I have a CMake list. Then the next three things are test has all my unit tests, source has implementation, so it has my CPP file. Include is what you would add to your include paths for any program that's going to use this library. And if it's not something that's built into the operating system, I like to have all the includes look like, hold on, show you guys. This where it's always some directory slash and then the file. And the directory is the name of the library usually. So in order to get that to work right, if include here is added to your include paths, and you said include base64 slash base64.hpp, you'll have this word base64 again that would match this directory name, and then the file, right? So that's why there's a little bit of redundancy here. You'd also have other directories if you had like a very large library with multiple pieces in it. Although that I usually don't do that because I don't like large libraries. I like the libraries to be very specific to the problem. So that's an explanation of a directory layout scheme there. All right. I like Visual Studio Code for renaming because I just select a word and hold down Control-Shift-L, and I can just type and it replaces it in lots of different places. And our tests, right? So SHA-1 becomes base64. Okay, and from our top level make lists, we'll add the subdirectory, base64. Hopefully that's all we need to do in order for CMake to pick it up. Oh, I did something bad. Did I accidentally corrupt SHA-1? No? Oh, it's probably complaining. No. I did screw it up somehow. Well, that's odd. It should be built. That's weird. Oh, I see. I forgot to rename something. Yeah, okay, here I forgot to rename stuff, so it got confused. There we go. And there's a bunch of other mistakes from copy paste that we got to clean up. So let's start with the tests. So we don't need this anymore. We don't have that. Base 64 tests. Well, I haven't thought about what the test will be so far, so I will just call it placeholder for now and remove all the things that we don't need. And then libraries base 64. We'll do the header first. This is new, so I can't claim copyright in 2016. So let's do the same thing we have, like, for convenience, the string and vector types. And it's not, we're not computing a hash. We'll have encode and decode. That's what we'll do. This function encodes the given data into base 64 using base 64. Using the base 64 algorithm. This is the data to encode using the base 64 algorithm. Base 64 encoding. And I think the comment is identical for both of these. And then let's make the decode versions. This decodes. There we go. And then CPP. Don't know what I'm going to actually need yet. We don't need this thing. Whoops. So bare minimum to compile will be something like return an empty string, right? Okay, so bare minimum. No test doesn't do anything yet. It's actually a little bit more than I should have done. Because the test doesn't use the functions yet, I shouldn't have even really declared the functions or implemented them at all if I was a purist. I'm not really a purist when it comes to TDD. Let's check this in. Well, hold on. It ran. Let me run all of our tests to make sure nothing's broken. I want to kind of check in base 64 as sort of a baseline, even though it doesn't do anything. So initial revision, work in progress. So the first time we push, we got to do push set upstream origin master. And then I will do Nugget add base 64. That does a couple things. It adds base 64 to our getignore, and it adds this section in the main.xml. We added the add subdirectory ourselves. And this change, for some reason, VS Code insists on doing that. I'm gonna remove that in a second. So add base 64 project. And let me remove that pesky file that VS Code makes that I don't want. By the way, this L for status, it makes it faster. It's local only, so it says question mark about what's upstream. It doesn't know, right? Without the L, it takes longer because it's having to go to GitHub and check to see what's the latest on the branch. And it's basically telling me nothing new except for Google test. Okay, so let's look at the base64 encoding, see for examples. I'm sure they have some. I like to pick examples from the spec because I know that they are valid. I don't have to chance making a mistake. Here we go. Test vectors, look, they actually give us a whole bunch. So let's copy that directly into here. And I had something like a test vector structure in our SHA-1 test, right? So let's copy that. And they weren't taken from there. They're taken from RFC 4648. There. Decoding, encoding. Let's just kind of shimmy these into place. So for here, I will replace base 64 open parentheses with curly bracket. And then for these, we'll replace n parentheses space equals with comma. And then we'll just tack these onto the ends. All right. So we'll do the encoding first. Encoding. Base 64 encode test vector decoding. And then we'll do expect that decoding matches the encoding if we do decode. So there we go. I don't know if we need to get any more elaborate than that. That tests the corner cases of that end character and goes past one or two characters, or one or two atoms, they call it. So this is pretty much complete. And we should be able to build that. But it's going to fail. That's what you want to see when you're doing test-driven development. You want it to fail the first time. All right, so nothing is being encoded or decoded. So let's fix that. So they describe the basic algorithm pretty verbosely. And what they do is they talk about there being an alphabet that's used to encode values. And the process takes 24-bit groups of input and outputs them as a strings of 4 encoded characters. And there's special handling when you're at, here, special processing is performed if fewer than 24 bits are available. You basically pad it to full 24 bits by adding zeros. So let's see if I understand this correctly. If for handling units of 8 bits, then there's 2 special cases, right? The last part of the string is only 8 bits long, or it's only 16 bits long. So we're either adding 8 zeros or 16 zeros. Why do they say an integral number of 6-bit groups? I'm not sure why they say that. Oh, it's not, okay, I see. It's not 8, it's 24 bits. Yeah, so our input is in multiples of 8, and our output is in multiples of 6. Yeah, okay, so let's take this dictionary and put that in to begin with. We'll just make it a simple lookup table. We should probably have it go in both directions, right? So from value to encoding, we can just make that a vector. For encoding to value, we ought to make that a map. This is used to find the encoding of the base 64, encoding of one, what do they call it, quantum group. One 6-bit input group. So let's use vector. So const standard vector. Encoding table. It's going to be characters, right? Actually, it would be better to just make it a string, wouldn't it? Actually, not even a string. Just an array. That way we can make sure that the length is correct. So const char encoding table. It has to be 64 long, right? Oh, hold on. Someone's at the door. I'll be right back. Someone's at the door. I apologize for that. That was an ice cream truck. My kids always get ice cream on Sundays, so. Let's fill in the dictionary. Okay, it's what we would expect. All letters of the alphabet. And then all the lowercase letters. And then numbers. And then plus and slash. And that needs to be 5 for the null character. Now we'll have a map to go the other direction. This is used to find the base 64 decoding of 1 6-bit. Yeah. The reason for the map is we could have letters like, or symbols like $, which is not a valid encoding. This can be a vector because it's always going to be a 6-bit number. And we need map. Const standard map from character to, I guess it's unsigned int would be the best type, right? Or how about just uint 8? Then we can. Yeah, because we're going to be forming bytes and stuff, so that makes sense. Decoding table. So this might get a little tedious. Let's see about how fast I can do this. B, C, D, E, F. 1, 2, 3, 4, 5, 6, 7. We'll just keep them 8 long. This is the tedious part of programming. I could build this programmatically, but that would be a little bit more complicated, right? I'm not doing this correctly. I would have to have some code run the first time, which would be a singleton, and we're supposed to avoid those. A, B, C, D, G, H, H. How did I go back to G? I don't know. Okay, let's line those guys up. All right. What happened there? How come it doesn't like that? Is it because these are... Oh, hold on. Before I get too far on this, I wonder if that's because these are not uint. What if I do int? Still doesn't like it? Why not? Cannot convert from initializer list. No constructor could take the source type. Or it was ambiguous. Cannot convert from initializer list to map. Really? Okay. Why not? Okay, map from... Oh, because those aren't characters, duh. Okay. Replace that with that. Okay, can I put that back to uint 8? Yeah, okay, good. Back in business. P, Q, R, S, T, U, V, W, X, Y, Z, A. Yeah, sorry about this being a bit tedious. I'll have to do it once though, and then we'll be done. Done forever and ever for base 64. Should probably verify that I'm not doing any typos. Okay, it looks good so far. Okay, and then the numbers. 32, 33, 34. Ah, get out of the way, IntelliSense. I think it's one more row, right? 4, 5, 6, 7, 8, 9, plus slash. Okay, that was enormously tedious. I never want to do again. Okay. So, basic encoding. We're going to be assembling 24-bit quantums, right? Actually, it would be more convenient to make this 32T. The way I'm going to do this. So, quantum and bits. So, we'll do 4 auto datum in data. And let us use a string stream, stream, for the output. O string stream output, and we'll be returning output dot string. Okay. Oh, let me look and see. What did I do for SHA-1? One of these functions calls the other, and I don't remember which one. Okay, the string one called the vector one. I guess that makes sense. Can I just copy this as it is? Oh, I actually don't like this mem copy thing. Wouldn't it be better to just say return standard vector unit 8t and then say data begin data.end? So we don't have to have mem copy? I think that would be better. Then we can do the same thing for this guy. Okay. So we're going to shift the quantum left by 8. And add base 60, add encoding table. Oh, hold on. It's 6, isn't it? No, hold on. Let me think about this. The data coming in is 8 bits. Okay, it's not quantum really, it's buffer. Buffer shift left 8 and then add the UN32 equivalent of datum. Right. And then we'll say while will this ever loop more than once? What's 5? 5 plus 8 is 13. Yeah, it could actually loop more than once. So while this is bits plus equal to 8, right? While bits is greater than or equal to 6, then we're going to shift out an encoding, right? Output shift out encoding of, it's going to be buffer shift right 6 minus bits minus 6. Masked, right? 6 bits is 3F. So it's going to take the top 6 bits, encode it and output it. And then buffer shift right 6 bits minus equals 6. And then for the end, it'll be while bits is greater than 0. Buffer, we're supposed to add what? Bits with the value 0 are added to form an integral number of 6-bit groups. Okay, yeah, we're going to end in either 8 or 16, right? Oh, okay, I see. Actually, can we just, yeah, we can just handle these two cases exactly. If bits equals 8, else if bits equals 16. It will be, we 0 pad it, so we need to shift 4 bits in. That's buffer, right? And for this one, next multiple of 6 will be 24. Right, it'll be 12, so it'll be 6 and then no bits shifted. And then they want 2 equals. And then if it's 16 bits, it's 3 of these guys. So 12, 6, and 0, and then we output 1 equals. So yeah, in both cases we're outputting a full quantum, right? Let's see if that makes our encode test pass. Didn't. Test vector, please. Okay, it's the F should have been ZG minus minus, and we just got Z. Oh, okay. If we have just one character here, then bits will actually be 2, not 8. So I think the condition is not that it equals 8, it's that output dot length. Can we get the length? We can't. I guess we can just count as we go. Size t, output length. And we plus this guy. If output length mod 4 equals and I'm not thinking about this correctly. Sorry, I'm reading this and thinking about how I'm going to do this. Oh, okay, so yeah, it's mod 3 equals 1. Or it's mod 3 is 2. Yeah, okay. Hopefully that fixes it. No, it didn't. Shoot. Oh, it added 2 more. That's wrong. It's set to padded, right? To form integral number 6-bit groups, yes. And then there are 2 groups. Huh. So I think I'm outputting too many here. So yeah, it'll only be one character. It'll just be that. And then in this case, it will have been 16 minus 12 before, so we're only going to add 2 bits and output 1, right? The number of characters is correct, but the last bits is wrong. Let me see how this works. Oh, hold on. Let me just think about this. What's G and what's capital Q? G is 32. Capital Q is 16. So it's 1 bit off. So did I do this wrong? 8 minus 6 is 2. Okay. I'm not seeing this for some reason, so let me set this. $66. Let me look at this in the calculator. Programmer. 102. So it should have been. Should have 2 left over, not 1 in the buffer. Somehow we have 1 left over though. Okay. Step by step here. Okay, 102, we have 8 bits. Put out the capital Z. Hold on. Oh, okay, I don't want to shift it right 6. I want to mask out. Yeah, okay, I did this wrong. This eats the wrong bits, so it's it'll be OX3F shifted left bits -6, is that right? Then invert that. Let's see if my guess is correct. No, it is not correct. Okay. Let's do this again. All right. $66 bits is 8, so it should have that shifted that left up to and then inverted it. Okay, that is correct. Bits is verse 32. Okay, so it got further. Is it the decoding's working and the encoding is not? Let me just filter this. Base64 encode. What's it called? Oh, I only have one test. I can't use a filter. Okay, never mind. Okay, so the encode for ZM9V is not working. So for 3 characters, what is it doing? It's adding more. Oh, I'm counting output. I should be counting input, shouldn't I? Oh, which means I don't need to count. I already know what it is. It's data.length. If data.length mod 3 size? Yeah. There we go. Okay, yeah, so all the encodings are working. Now I just got to do the decoding. All right, decoding. So it's going to be the same kind of thing. For auto group in data. Actually, we'll just say datum in data, but each one of these we need to look up in the decoding table. Const auto entry equals hi there, Joshua Golaher. I'll just call you Joshua, if that's okay with you. Find datum. If entry, we have to be prepared here. Last name is strange. That's fine. Decoding table.end. We have to figure out what we're going to do for an invalid encoding. I guess what we'll do is we'll just replace it with something. It doesn't really matter, does it? So we'll say actually what'll work is if we just use 0. So group 0. Group equals entry second. So yeah, so we'll have the what they call it? What they call it in the standard? Quantum. Quantum. Well, that's not exactly right. We'll just call it buffer. Buffer. Buffer shift left 6 buffer plus group. Plus equals group. And then we'll say while or if. You can never get up more than 15 bits, right? So if buffer, hold on, we have to count bits too. Size plus equals 6. If bits its size is greater than equal to 6. Do I have this loop? Yeah, same kind of thing. Oh, I called it bits though. Let's call it bits here as well. Then yeah, we're gonna have to have the same kind of construction. Output. Return output. Dot string. Output shift left. Converting to character. Buffer. Shifted right. Bits minus 6. And I guess it would be polite to mask that. Oh no, it's hold on. It's 8. 8, and we don't need to mask it. Buffer shift right 8. Bits minus equals 8. And if we don't have a complete quantum, we'll just not care. Because I think that makes, oh, hold on, some extra junk at the end. Why do we get extra junk at the end? Let's run through this. I think it's when we have this CG blank blank. Needs to be F, right? So 25. Then G. It'd be useful to look at in hexadecimal, wouldn't it? It's going to shift right 4, that value. Calculator, please. Two. Oh, okay, I did it wrong again. It's not shift right 8. It's the same bug I did back up here. I need to do this. So in this case, it's that minus 8. Yes, please stop debugging. Getting there. I end up having 2 blanks at the end. Let me think about this. Yeah, we need to remove the padding. Oh, I know what we can do. We can count the padding. Yeah, we added 2. If we have 2 at the end, we chop off. Okay, we're going to chop off the number of bytes equal to the number of equal signs, right? So I think what we do is we only want to shift it out if the datum is not the special marker. Does that work? It works. Cool. Let me check that in. It actually wasn't that pleasant to implement that. Probably because I didn't implement it the best way. It's probably a smarter way to do it than that. Okay. Implement base 64 and encoding decoding. Yeah, let's move on to more pleasant things. So, okay, strong entropy random numbers. So let's start off. We're going to switch gears a little bit. We're going to be moving over to the system abstractions library. Let's close all our windows here. Close. Oh, let's use VS Code for this. Close all this stuff. System abstractions. So let's make a test for it. Doesn't really matter what test we copy because I just want the boilerplate stuff. And this is, we'll call it crypto random. Or should we call it strong random? Crypto random's cooler name, isn't it? crypto random tests. Crypto random. Yeah, we'll make it a class, why not? And source. Include. So include, we'll add one called crypto random. Crypto random. And we'll make Win32 and POSIX. Crypto random Win32 and crypto random POSIX. Although it's not typical, it's not actually POSIX, it's Unix-like. Okay, first the interface. Or hold on. Backup. CMake. We need to include the header. It's after clipboard. Crypto random. And then the sources, we have a Windows specific source. I'm having the hardest time typing the word crypto today. And then this right here. It's messing with my indenting for some reason. Crypto random POSIX, right? Might need an impl also, now that I think about it. Oh, we'll see. We will see. And then the unit test needs crypto random tests. Actually, how are we going to test crypto random? That's gonna be a bit tough. I have no idea. I have no idea. Maybe we'll just call it and make sure that we get something different every time we call it, and then we'll just call it a day. Even though that's not really testing strong entropy. Okay, collapse all. We're looking in tests, system abstractions, source, crypto random tests. Okay. Don't know what we need yet. Yeah, I could do what I was doing there before and like mock out the OS interface, but I'm not liking that. Let's see. Yeah, get rid of it. We don't need a fixture. We'll just have one test called generate. What we'll do is we'll say system abstractions crypto random crypto. Okay, I already misspelled it once. Crypto. Oh, I misspelled it twice there. Bad. Crypto. And then crypto becomes crypto. Alright. Yes, please reload. Alright. Crypto random. Generator. And then we'll say, I don't know, for... Let's make a set. Actually, you know what we'll do? Is we'll make a lot of random numbers, and we'll make a count of how far away from the mean they are, and we'll just what's an easiest way to look for a bell curve? That's what we expect, right? Or no, we expect a flat distribution, a reasonably flat distribution. Yeah, let's do that. So, What's the best way to measure how flat something is? Bin it and then count the number of things within each bin? Well, if we ask for bytes, that's only 256 bins, right? So we don't need a set. We can just have size t count. Counts 256 equals that. Start them off at 0. Let's do it the C++ way. The C++ way would be vector of size counts, and that is parentheses 256. So for some huge number, how about 1,000,000? That's probably how about 10 million? Let's see how long that takes actually. We'll say counts. Well, first buffer, right? And we'll say generator dot generate address of buffer 1, right? Counts buffer plus plus. So how do we measure the flatness of this? Probably by measuring the maximum difference from the average. So we'll have an average. We'll have a sum, which should add up to 10 million, by the way. I guess we can compute it as we go, right? Sum plus equals buffer. No. It's the sum of the counts is what we need. Yeah, so it's for auto count and counts. Sum plus equals counts. Count, right? Size t, const size t, or const auto average equals sum divided by 256. So it'll give us the average count of all the bins. So what do we expect? That it not deviate more than like 1%? So for auto count and count, let's make the average an int. Just so I can take differences a little bit better. And that's, yeah, we'll make these all int. Just because then I can take a difference and not worry about having to convert things to signed. So const auto difference equals count minus average. And in C, what is it to take the absolute? ABS? Standard lib, okay. Standard lib, so ABS of that. And what? Assert or expect less than or equal to? How does that work? Is it the first argument less than or equal to the second one? I think so. Well, I like this better actually. True. No, I don't, because I want to show both the left and the right. So difference, and then we'll say average. So that'll be 1%. I don't know what if that's too strict or too lenient though. But we'll see. That won't build, will it? Because of all sorts of things, all sorts of crazy things. For one thing, we got to actually set up the interface correctly. System abstractions, header, crypto random, and it's got a lot of junk we don't want anymore. We don't need this. This is used. Oh no, we don't need that. Namespace system abstractions. This class represents a generator of strong entropy random numbers. Okay, we don't need this stuff, do we? Or wait a minute. Yeah, well, I copied this from somewhere and it's the old style. I never did refactor that. This stuff I like to group together and delete by default. I like to follow what's called the rule of 0 or 5. And I call them life cycle methods. The rule is that if you declare any one of these, you declare all 5, even if you mark them as deleted. And that's destructor, copy and move construction, and copy and move assignment. And I've been adding no except when I can for these methods, just because I ran into a situation once where the compiler didn't want to use it. I think it was the move constructor or assignment, unless it was marked no except. Okay. We'll have a default constructor. We don't need any of this other stuff though. Except we had a generate function, right? And that was returning, no, that was not returning anything. That was just generate, and then it took, I suppose we don't really care what, in the interface, what type it is. So buffer, and then we want a size or length in bytes. This method generates strong entropy random numbers and stores them into the given buffer. This points to a buffer in which to store the numbers. This is the length of the buffer in bytes. Okay. So let's do the Windows implementation first. Oh, not clipboard. Not clipboard. Cryptorandom. Cryptorandom Win32. This contains the Win32 specific part of the implementation of the cryptorandom class. And we just invented it, so yeah, these copyrights need to be not retroactive to some old date. Okay. Okay, fine. I believe what we want, besides this crypto random, is we want whatever this MSDN page says. I think it's bcrypt bcrypt.h. This is the Win32 specific state for the crypto random class. I actually don't think we need anything, so it can be empty. And we don't need any of this junk. We just need to fill in the destructor and constructor. We can default that one. Whoops. And then the generator. Well, commit doesn't like that. Oh, for that we need memory, right? And for the size t that we used, we also need standard def. Okay. So according to this, we just call bcryptGenRandom, and we don't. It better work. bcryptGenRandom algorithm, I think, is null because it says down here, if you use the preferred RNG, we need to set algorithm to null. Required when Dito flags includes this. Second argument is the buffer. So that's just buffer. And then the length of the buffer. It's going to want me to typecast to these absurd types, poochar and ulong. That's fine. So bcrypt there. I think that's all we need to do. Can we build that now? Yeah, so it can't resolve it. To get that, there was a trick that I used with pragmas. Here it was. So then we just include what they say we need to include for DLL. Bcrypt. Okay. So let's see what happens when we run the test. So system abstractions test debug, and I'm gonna filter to random. Ooh, okay. So it's more than 1%, but okay, so let's make it 5% just for good margin. Okay, it takes a while, 1.3 seconds. We're generating 10 million random numbers. Out of curiosity, let me see what the average is and what the largest count is. Largest difference equals 0. And we'll say largest difference equals the max. For that we need algorithm. Largest difference and difference. Average. Largest difference. Average, largest difference. There we go. So is that right? We take 10 million and divide by 256. Do we get around, yeah, 39,062. I suppose we could build that into the test. Yeah, so let's build that in. So expect, will it say expect near 39,062 within, I don't know, is it 10 that we expect it to be near? Then what's 5% of that average? Divided by 20. So okay, this is my poor man's way of making sure that it's a reasonably flat distribution. Is that the average is near, well, I can actually put this in directly, right? And let's, for kicks, say, make this a constant. Iterations. Okay, cool. So it works. Now I don't have my Linux box running, but we could fill in something for the Linux thing based off of urandom. I just won't be able to test it right now. So let me take the contents of cryptorandom 132 and go to POSIX here and paste that, and we'll put it in there, but not be able to test it right this moment. We'll say this is contains the, it's not technically POSIX, is it? It's Unix-like. Okay, there's no windows.h, but if we're going to read from a file, we're going to want standard IO. If we're going to use a C library. Oh, hold on. This pcrypt should be first, shouldn't it? This is the POSIX specific state. So here we'll want a file, urandom or RNG. We'll say this is used to read the dev urandom device. Well, it's the random number generator device. So here we'll say impl RNG equals fopen dev urandom read as bytes. I wonder if it's better just to use straight on files. How did we do that in file POSIX? We just made a handle, which was an int. So int. And we just did open. And we did read only. Yeah. I actually like that better. Less middleman, right? And then close is just close. So do this. Void close impl RNG. Hi there, shocking coding. You don't need to use const expr with a literal class like standard size t. The compiler will automatically set it to const expr even if you just use const. Sure. Where was I doing that? In my test, right? Something like that. I kind of like to use const expr because if you read it, then you know it's a compile time constant. But so if I accidentally did something like counts.size, that shouldn't compile anymore, right? Yeah, see, it says it has to be a constant value. So I'm kind of making a statement in the code here saying that I want it to be compile time constant. But you are right. If I didn't care about that, I could just say const there. I guess you'd say it's a personal preference. So yeah, if there's a technical reason why it's better, like do you know if there's a reason why that might be better than that? Then I'd be willing to hear about it. Always trying to learn from my mistakes. I just don't know if you're saying that if I just could do that if I wanted, or if I should do that. Okay, random. I was looking at POSIX, right? So to generate one, I think we just read, right? Simply personal preference? Sure. Yeah, I'd accept that. So yeah, if I was reading someone else's code and they used const, I'd be like, okay, cool. As long as it's readable. To generate, just make sure I'm doing the read correctly. Where's the read? Oh, that's down here. It's read handle buffer bytes, and we return something which I don't care. Read RNG buffer length. I think that's all we need. C++11 is what I'm trying to use. I don't know C++14 and above well enough. And one place where I kind of make that statement is in my top level CMake. I say what version of the standards I'm using. I'm sure over time I'll learn enough 14, 17, 20 to bump up to that, but I'm not comfortable enough with it yet. Also, I want to make sure that the tools exist on all platforms. So I use Windows, Linux, Mac, and Raspberry Pi, which I guess is Linux. So if the compilers all support, let's say C++17 on all those platforms, then I'd probably make it a point to learn and start using them. Someone was telling me yesterday they weren't sure if Visual Studio supported all the C++17 yet. Okay, so I don't have the ability to test this at the moment, but we'll just leave it there and fix it up later. Just running my tests, and then I'm going to check this in. Okay, I made some change to the root. I need to look at and see what I did there. This was just adding crypto random tests and crypto random. Add crypto random class. Huh. Oh, again, it's this VS Code thing. I wonder if I should just mark that as ignore for now. Yeah, it insists on doing that. Let's quiet down Git to say don't worry about that. So .vs code settings.json. Pacify Git in regards to a file that VS Code likes to touch. Okay, assuming that's all checked in, yep, so we'll move on. So we did all of this. Time to either, this one's going to be a longer one. Maybe what we'll do, I didn't have it specifically listed here, but this strong entropy, we're using it in a specific place in WebSockets. So WebSockets, we'll go and we'll tell it we need, in addition to HTTP, we need system abstractions. And then in the code, we reload it. It's one of these to-dos that had entropy. Here we go. 222. Include system abstractions, crypto random. And we'll make it a property of our implementation. This is used to generate masking, is it masking keys? Yeah. That have strong entropy. RNG. Okay. So here we'll have masking key, and then we'll say RNG dot generate masking key. Size of masking key. Cool. And let's get ready to run our WebSockets tests again. All right. Integration complete. Use system, let's say fix, well, it's an intentionally inserted bug in masking key generation. Use system abstractions, crypto random to make strong entropy random masking keys rather than using a fixed arbitrary number. Okay. Yeah, so I guess we'll handle the open handshake function now. So all of that was, okay, it's going to be a slight change to WebSocket, right? Because we have this open, and it puts it into the open state. So I think what we should do is just expand upon that, and we'll pass in the original HTTP request and then response, and we'll have the open do the handshake and return whether we'll have it return whether or not it should succeed. Or no, it'll be evident in the request and response. So okay, it's already using HTTP. We just need to pull that in. So request and response. Someone was trying to teach me yesterday, so I'm going to try to learn that if we're not going to modify the reference count, which we're not going to for the request and response, we should be passing a pointer or a reference. So let's do that. So let's ask for a reference to the request and a read write pointer for the response. This method puts the WebSocket into the it's opening. Actually, we need two versions of this, right? We need to say open, either open as a client, and then that generates, or it updates a request, and one open as server. I think that's what we'll do. So we'll have this one open as client. Another one's open as server. So open as client is going to go into the opening. Hold on. If we do open as client, we're going to fill in a request. And then later we'll need another call to receive back the response, right? So start opening. Start open as client, and then complete open. Finish open as client. Where we're given the response we get back. I think that's what we want to do. And then open as server. Kind of gets both then. But it modifies the response. And I suppose we should say whether or not it succeeds or fails for both of these. This is modify. That should just fill, that just does the client side of the handshake, which modifies the request. This one deals with the response and either succeeds or fails, and then this one, I suppose we can also make it return a failure if we want, but it'll be indicated in the response as a failure code anyway. Still haven't needed to use shared pointer. Always use plain unique pointer. Suppose you need that because, yeah, actually we are sharing it. So the WebSocket's sharing a connection with the server, and it'll hold on to it. It's basically handed off from server to client, but while opening, both of them have access to it. This puts it into opening state in the client role, updating the given HTTP request in order to perform the opening handshake. I'm actually thinking I should keep, for testing purposes, I should keep the old open method because I use that quite a bit in my unit test so far. This one that takes a connection and a role, so I already blew it away. Let me get it back from Git. Smart pointer is really useful. No more dangling new definitions. Yeah. There's a really cool. Let's see if I can find it. It's something I really like to do now. Like, see if I can find this. Yeah. So here's a cool way to encapsulate something in C that you used to have to remember to close the file. So what I do now when I want to use, in fact, I should use this in my crypto random for Linux, right? Is when you call fopen, you take the result and you wrap it into either a shared pointer or a unique pointer. It doesn't matter because both of them can take this. I think it's called a deleter, and you just make the deleter say if it was open, close it, and then it doesn't matter where this config file, for example, gets goes out of scope, whether if you're throwing an exception or not, or storing it somewhere and later releasing it, it'll call the f close at the correct time, which I think is really neat. Deleter, very useful, yeah. So I blew away the close. I mean the open. I want to get this back. Basically I want these strings back. Dog barking at someone at the door. Let's recover this open again. Bark, bark. Yeah, overriding the standard. The standard deleter just calls delete, so it kind of assumes you called new. So if you didn't call new, if you called fopen instead. Exactly. Okay, I want to recover this comment here. Okay, this is still there. Sorry about the dog barking. Trying to mute it, but she's faster than I am. Roll, roll. Yeah, oh my dog. Exactly. Or what's the other one? I already forget what it is. Frankersy? Yeah, so this is to bypass the opening handshake. And we're using this mostly in our tests. Hold on a sec. Okay, yeah, so we're keeping that around. Let's move it so it's underneath the normal handshake ones, though. This puts into the opening state in the client role, updating the HTTP request in order to perform the opening handshake. Right, so there's a connection. Actually, do we need the connection for start? I don't think we do. It's only when it finishes the request, and this is both in and out. This is the HTTP request that will be used to perform the opening handshake of the WebSocket. The method updates the request to include the proper headers. So this one needs the connection again. And this one's in, out, just in response. This, okay, hopefully, optimistically, it puts the socket into the open state, open ED state, in the client role. By checking the given HTTP response returned that completes the handshake. Out of curiosity, you see that I need to generate random numbers, and I'm using that crypto class. Currently needed random numbers too in a program. How do you generate them? Oh, I went through that a little bit earlier. Let's look at it again. By the way, you can get this code from GitHub. I have a link below. So for Windows, I'm using the bcrypt gen random function on Windows. I don't know what OS you're on, so I'll show you both. The function, I just looked it up this morning. I used to use crypto random, and it said it's deprecated now, so they recommend this bcrypt library. For Linux and Mac and all, Unix-like, I use dev random or dev urandom. They recommend you use dev random if you want it to be cryptographically secure, but the problem is right here, if the entropy pool becomes empty, it'll block. So I didn't want to deal with the RNG possibly blocking, so I'm using urandom, which is the unlimited one, which reuses an internal pool. It says it won't block, and it says it should be suitable, but theoretically there might be some attack, and so if you're concerned, use dev random instead. So that's just a file, so it's super simple. You just read it. Read the dev urandom, and you just get random bytes. Yeah, I think this bcrypt gen random, they talk about what it uses. It complies with NIST SP 800-90 standard. So I guess if you look that up, they supposedly comply with it. And someone said that it'd been revised and it's compliant with the revision 1, yada yada. I'm not really that knowledgeable about crypto stuff, but I assume that internally they do the same things that this Wikipedia article talks about, where they get entropy from all sorts of different truly random sources, and they just kind of mash it together. So yep, that's basically it. And if you're on Windows, you got to include bcrypt, and then you have to link with the bcrypt library, and you use this preferred RNG. If you have a specific one, you pass its handle there, and you make the flag 0. Okay. back to here. This puts it into the open state, but checking the given response turn that completes the handshake. Yeah, so it's possible that will fail. This is the response that completed the opening handshake of the WebSocket. This response may indicate that the handshake failed. An indication of whether or not the opening handshake succeeded is returned. Then we'll have the same kind of thing for server. In the server role, by checking the given HTTP request and filling in the given, or updating the given HTTP response accordingly to perform the opening handshake. Request. This is the request. Well, hold on. One of these is updated, right? I'll just duplicate that and update it. So the response is updated. The request is not. It completes the opening handshake. This response may be updated to indicate that the handshake failed. I just got a box of cookies given to me. That is sweet. Okay, update. This is the oh, I misspelled request. Request that initiated the opening handshake and usually doesn't indicate failure. All right. So let's make a test for this. I should have written the test first, but I was lazy. Initiate open will be calling it from the client side, right? So WS, we need to make a request, don't we? And we're going to be filling in a response. So start open as client request. I guess we're not dealing with a response yet, are we? Initiate open as client, maybe? Because we'll want to have open as server as well. Or complete open as server. Okay. So what do we expect? I'm going to go look back at the spec for this here and look at their example handshake stuff. Here it is, opening handshake. I want an example where it shows both. Okay, here we go. So it's going to be filling in stuff like the WebSocket key. We're not going to do that. That's used for sub protocol, so we're not going to handle that quite yet. But we do want to put in a version number. So expect equal, I think is it 13? Just checking. Must be 13, okay. Back up to the example. 13 for request.headers.get header value, not multi-value, value sec web socket version. And for this key, we'll just expect that it has the key. Actually, we'll do two things. Well, yeah. I'm wondering how are we going to verify that that's good? I guess we could base 64 decode it, but something that's bad might still decode to something. Oh, I know what we'll do. We'll decode it and then re-encode it, and it needs to be the same string. Yeah, I like that. So we're gonna need base 64 that we just made today. Do I still have a Git GUI window open? Okay. Right, because I wanted to get some of that text back that I lost. So we'll have base 64 available. So true that it has one. Well, assert, because we can't continue if it doesn't. What is it not like? Oh, has header, okay. Man, I had to talk to my family about slamming doors. Right, so let's get the header. Decode and then encode and make sure it's the same. So const auto key equals get header value that. Assert or expect equal. We expect the key when we decode it, we encode the decoding. Decode the encode, no, encode the decoding. Yo dog, I heard you like base 64, so I put encoding in your decoding so you can encode while you decode, right? That was probably awful. Don't listen to me when I try to be humorous. Sometimes Visual Studio does that. It'll put a red squiggly like right there, and like when I just hit save again, it goes away. Anyway, what else do we expect? These two things, right? We need to have upgrades WebSocket, and we need upgrade to be in the connection token. I think that another thing I need to check. These can be case insensitive, right? I think I might have made a mistake yesterday. I need to make a note for that. Note. Check HTTP server for close token. It probably needs to be case insensitive. Because they, I just noticed that they're using capital U there. I believe that it could be lowercase u and it's still supposed to match, so we'll expect equal. I know, we'll just do two lower on it. I have that in my system abstractions, right? String extensions. Oh, I don't. I should probably add it. Where do I have a two lower? This one. Yeah, I need to move this guy. Let me make a note to move that guy later, but right now I'll just do a copy because I don't want to get too distracted. Move to system abstractions. So right now I'll just make a local copy of this guy. I'll even steal his documentation. Yeah, because we're going to want to do this. WebSocket. Normalize the case request headers, get header value, upgrade. Okay, and what was the last one? It was it has to have upgrade in the connection list. So the connection can have more than one token in it. So we'll have to do something like this. Found upgrade token for const auto token in request headers get header multi-value connection. And this does what I expect, right? It splits it. Oh, it doesn't. Well, when it parses it, it splits it, right? Actually, no, I'm not so sure. This might not be the right thing. How did I handle this in the server? Asking myself questions like I'm on trial or something. Close. I did use get multi-value. That might not be the safest thing to do, is it? Yeah, because this one doesn't split it. I'm just jumping around here just to see what happens when I'm parsing. Okay, separate name from value. Yeah, this doesn't do anything about splitting it, so I gotta be real careful about that. So I think I use this in many places, so I need to make a utility function in HTTP to split up tokens from header values. Every time you use auto in your code, you feel bad because you're too lazy. Isn't the definition of a good programmer someone who is as lazy as possible? See, I rely on my IntelliSense to tell me, yeah, that's a string. It's a personal preference thing, though. Some people, it really annoys them, I think, to have auto everywhere, and they'll put standard string. I like auto because I get into situations where I use templates, and then the name would be something like standard map of standard vector of BLAS, and that's standard string. And I know I could use using namespace standard, but this is a real lot harder than to read than something like that. So I guess it's a habit I got into, a lazy habit. So for each value, this is really could be a token group. We're going to want to split that up. Use auto when the class type is like yeah, that's exactly what I do. But I've gotten into the habit of maybe overusing it. Okay, we have a split. That's great. So split isn't going to trim either, so we need this first split. Token with white space in system system abstractions string extensions. Are we including that NRC make? Nope. Let's be polite and include it directly because it's a direct dependency and not rely on transitive dependencies to get us what we want. Split token group on comma if like heavily templated types. Yeah, exactly. Using type def, using keywords. I really avoid doing using because using is taking two namespaces and smashing them together. I don't like that idea, but as a result, I'll overuse things like std::. Right? That probably annoys some people too. They're like, why don't you use a using namespace std? My response would be, I don't like smashing namespaces together. Okay, I need to say if trim token with white space. And now if that equals, and then 2 lower, right? Oh no, I made a normalized case insensitive string. This is actually getting quite elaborate. If that equals web upgrade. Oof. A lot of work just to see if we can find the upgrade token. And then assert or expect true found upgrade token. Yes. Typedef is not the same. Typedef is assigning a new name to something. Assigning new names is okay as long as it's a unique name. Using is smashing together. Okay. I didn't provide a body for start open as client. Actually, I didn't provide a body for most of these things. Ooh. Indentation alert. Okay. While we're at it, let's put in some lazy implementation of the other two. What's the laziest thing we could do for this? We could say, nope. Open a server, same thing. Say we will have none of that opening here. Return false. Open failed. Alright. Okay. What are we in now? We're in WebSocket. WebSocket test debug. Run the test, please. And let's filter it to be initiate. Initiate open as client. Right, so we're not setting the version to 13. We're not setting the key. So let's go do that, shall we? Open as client. You don't use using when typing to use elements from namespace to the global one, but just renaming. Isn't that sort of a syntactic sugar for a typedef? All right, take it easy. Have a good sleep. See ya. So start open as client request dot. Yeah. Yep, like typedef. One of the problems I have with C++ is there's more than one way to do the same thing, and it's not clear. It's either not clear which one's better, or it's open to personal preference. Anyway, it's all good. Have a good one. Headers dot. I guess we want to do a set header. Sec web socket version 13. And let's make this not a magic number, but currently supported WebSocket version. Can I make that const expr? I don't think so, because it's a complex type, yeah. It's one case where const is better, because it's a complex type, it can't be built at compile time, obviously. This is the version of the WebSocket protocol that this class supports. Alright, let's get past these tests one at a time. Okay, it doesn't have a WebSocket key. Well, let's make one. It can be anything, right? Let's see what the standard says for it. Key. "16 bytes in length." But what does the value have to be? Must not appear more than once. Okay, but what? It doesn't say what its value should be. It just says that it has to be 16 bytes and it can't appear more than once. It's a nonce. So it really should be something that we generate randomly, I think. Oh, here we go. Randomly selected 16-byte value that's been base64 encoded must be randomly selected for each connection. So that means what we will need to use cryptorandom, which we already have included, so that's great. So, okay. uint8t nonce. It's got to be 16 bytes, and we'll say rng dot, or it's impl rng dot generate nonce, size of nonce, and then request dot headers dot set header sec WebSocket key. Actually, we should probably put that into our state, right? So we don't have to re-encode it when we're going to check the completion of the handshake. So that kind of would go up here. This is the nonce, or this is the, what did they call it? Wait a minute, it's not necessary for the server. Oh, okay, yeah. It doesn't say really what it is. It's just something. It's just a thing. Okay, this is the randomly generated data used to form the sec WebSocket key header sent in the HTTP request of the opening handshake. When opening as a client. So this becomes impl nonce. And then we say base 64. Oh, we don't have base 64 included. Let's do that. Base 64. Base 64 encode the nonce. Oh, okay. String would be nicer, right? So we will make this we'll just make it a string on the fly. Standard string. Impl nonce. size of impl nonce. Is this a case of excessive indentation? Probably. That's more pleasing to my eyes, at least. Okay. Okay. So it didn't have, the upgrade one didn't have it, so we need to add that. So request.headers.set header upgrade WebSocket. And we need to add the token request.headers.get header multi-value. Connection auto connection tokens equals that. Connection tokens dot push back upgrade request.headers.set header, or is it set header takes a vector overload, right? Yes, so connection tokens as one line. True. Actually, I was thinking before that I needed to do this split thing, but I don't think I do. Actually, I do. I do need to do that. So yeah, unfortunately, I need to make. I'll make this a helper later. Or hold on, maybe I should just go ahead and do that now. Yeah, maybe it's worthy of separating this into a. Yeah. We'll take a little diversion into HTTP. It's actually not HTTP, it's message headers. Get header multiple values, right? Kind of like, okay, so maybe not exactly like that. New test. We'll call this get header tokens. Let me copy the guts of one of these guys. Raw message. Foo. Bar spam. Hello. And bar, just one word, foo. Don't really need to check this though, but here's where I will check it. So I want a vector of strings from headers get header tokens, which is a new function we're inventing for foo. What I want to see there, hold on a second, let me take a small diversion back here. What does set header with a vector do? It does that. Yeah, so the complement of get header tokens is set header with a vector and one line true. So I expect bar, spam, and hello from that. And from my other test guy, it's only one thing. Okay, so let's define this guy. So it's a lot like get header multi-value, only it's actually going to break up into tokens. This method returns a sequence of tokens extracted from the headers, the header with the given name in the message. This is the name of the header whose tokens, whose values should be returned as a sequence of tokens. A sequence of tokens extracted from the values of the given header are returned. This will return if there is no header with the given name in the message. Yeah, okay. I suppose we'll also do the normalization too, because these kinds of things, I believe they're always case insensitive. Let me verify that though. So that was in the HTTP-RFC. This one. Well, really this one. And it's token. Case insensitive. Case insensitive. I think they're always case insensitive. I'm just going to assume they're always case insensitive. So, okay, this is another place where I can do that and then not have to repeat myself. Okay, so we're going to, again, be making values, or really tokens, and returning them. But I already wrote this, didn't I? I wrote it in WebSocket tests. For token group in get header multi-value forwarding the name, for token with white space is we're going to need to make sure we have system abstractions. We don't. Really? This thing doesn't use any of that library stuff? Do we have split locally maybe? Strip margin white space ends with combined strings. Really? I don't have split tokens? That's the only thing I use from system abstractions. Okay, there's also trim. That's margin thing, right? Where was it? It was up here somewhere. Strip margin white space. Yeah, okay, so I'm gonna take that split function and make a local copy, because I don't want to pull in that dependency just for one little function. Although I guess I shouldn't really worry about it. Split. Oh, I'm already trimming stuff off when I split. Okay, that's a little bit better. Split tokens. This function separates the tokens in a string. Keep it short and simple. S. This is the string to split into tokens. We don't need that. Return. The list of tokens is split from the string is returned. Trim becomes strip margin white space. This is hard coded. This is tokens. Okie doke. So this becomes split tokens. Right, so then I can say tokens.insert tokens.end this thing. Hold on, I can avoid the insert actually by just saying split tokens, token group to tokens. Can't I? And get rid of all this stuff. So just change this around a little bit. And this becomes an in out. This is where to put the tokens split from the string. The new tokens are pushed onto the end. Okay, so build that guy. Message headers, test, debug, message headers, test. Okay, it didn't work. Why didn't it work? Cry, Bible thump. Oh, I never parsed it. Well, that would explain it. Parse those headers. Okay, cool. So we added this, which was going to be very handy, actually. Add get header tokens method. Okay, back to WebSocket tests. Yeah, because now it's a lot easier. We just do token and get header tokens, and we don't need to normalize it. We just say if the token equals upgrade, bound it. We could make another utility called has token, but let me put that on the notebook to consider. Consider adding message headers has header token. All right, but this, let's see how far this gets us now. Oh, cool. So the initiate handshake works. So we've done one half of the client-side handshake. Yeah, it's really just setting the key, setting it to upgrade, all that stuff. So finish. How do we know if it finished is if we get a correct response from our handshake. So let's go back to find our handshake example. So we needed to say 101 switch. We have to say 101 is one requirement. It's got to say upgrade WebSocket. It's got to say connection upgrade. This accept, and it has to match our nonce, right? Those are those four things. So if response dot status code is not 101, return false. Let's be optimistic that we're going to return true at the end. And we will do the same thing that our test does, actually. Oh, I'm looking at the wrong thing. Oh, we should make the test first. What am I thinking? So we start by starting the handshake, and then we'll assemble a response. Response.status code is 101. Response.headers.set header connection upgrade. Response.headers.set header upgrade WebSocket. Connection upgrade WebSocket and set header sec WebSocket accept we have to see how this is formed, right? We can concatenate this string and then take the SHA-1 hash of it and then base64 encode it. So that's a lot of work. We need SHA-1. While we're at it, we're going to need to add that to the WebSocket CMake as well. Key accept. We're going to form that. So it's the request.headers.get header value of sec WebSocket key plus this string, and then SHA-1 that guy, SHA-1. SHA-1 that. And then what do we get back? Another string, and then we base64 encode that one, right? Actually, so we can just fill this in straight into here. Because why not? That's how I roll. That's how we roll. Extreme indentation. Now those are all the things that we need to fill, right? That we're expected to fill. 1 to 1. Blah, blah, and blah. Okay. So, assert true. WS dot complete finish as client. Okay, we need to give it a fake connection. So connection and the response. Need a fake connection. One of these guys. Well, I guess we don't really care to use it anywhere else, so just make one and what do they call that? Tear off? Make a tear off and give it to it. All right. One bark got through. Another bark gets through. She's barks so quickly I can't mute it fast enough. Okay, so we verify status code. We need to verify the upgrade. Where was that? This kind of thing here. Found upgrade token response. If not found upgrade token, return false. You know what? We can also just break out of that if we find it. There too. If response.headers.get header value upgrade is not equal to, well, actually we need to system instructions, no. What is it? It is in system instructions, right? String extensions. Oh, okay. I made a note to do this, but yeah, to move it. Shoot. Making yet another copy. We'll just go and, as a refactoring step later, we'll be removing all these redundant copies of things. It's not equal to WebSocket. Return false. And then finally, we're going to do the same thing the test does. Oh, which means that we don't really need our own nonce, right? Not equal to, yeah, we don't, yeah, what am I thinking? So first thing is this thing we ought to just define as a constant. Constant or string, what is it called, salt or something? WebSocket key salt. I don't know if that's the right name, but I'm going to say it. This is the string added to the sec WebSocket key. before computing the SHA-1 hash and base64 encoding the result to form the sec WebSocket accept corresponding value. We should make a helper for this too. So not equal to compute key complement key answer to our nonce, I guess. But we'll change our nonce. Return false. Let's go change our nonce. So our nonce, we need to make where we have the nonce here. We'll just make it local, right? Generate it. But here, when we base64 encode it, we'll store that as our nonce. Well, we'll call it key, actually, not instead of nonce. Key. This is the base64 encoded, randomly generated data set for the key header sent, and yes, okay. So key equals this. So we say that because when we answer it, we're going to compute the key answer and compare it. I'm making this a separate function because we're going to want to compute key answer and open a server. Here. This function computes the value of the sec WebSocket accept header, that HTTP response header that matches the given value of the sec WebSocket key HTTP request header. Param key is the key value for which to compute the answer. The answer computed from the given key is returned. All right. So I guess I could cheat and just copy from our test here. Sort of copy it from, except for instead of this, I'm going to say that this is the WebSocket key salt. We need to include SHA-1, of course. And this just becomes key. Key plus salt. Return that. How come it doesn't like that? It builds fine. My IntelliSense is just broken. Okay, this happens more and more often now. It's like once per stream. I have to stop Visual Studio and reload it again. It still doesn't like it. Okay. When this happens, which happens once every 2 or 3 streams, I gotta go to my shell in my build here and just remove the .vs folder. It's not going to remember where we were, so I've got to find it again. There we go. Cool. So we have client handshaking done. So let's do the open a server one. And then I'm probably after that, what else do I have to work on? Catch protocol violations? I might get to that, but I might not, since I'm already past 3 hours. We'll see. We'll definitely finish up the handshaking stuff. I don't think I'm going to be getting to the chat room today, but maybe tomorrow. Compute key answer yes. So test first. Where was that? Here it is, to do. Okay, complete as server. Yes, so will be open as server. Assert true that, and it's takes a request and a response, and it wants a connection as well, which it will use later, but not part of this test. So we can just give it any old mock connection for now. HTTP response. I already had the type there. We need to fill in the request. So the minimum stuff that the request will need, right? Didn't we do this already? Okay, we sort of did it, but as an expect thing, so yeah, let's turn this around. So instead of setting, we're gonna set, and we're gonna put the 13 there. And then again set header. It's gonna be I don't know, we need a random number. It doesn't really need to be anything in particular, but it has to be 16 characters long, right? So A 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's the key. What else was there? Oh, upgrade and connection. Did I? Yeah, I had that in there, right? Yeah. Connection, upgrade. Upgrade. WebSocket. Connection upgrade, upgrade WebSocket. The other stuff is not of the concern of the WebSocket, it's more the concern of the HTTP server. So we open a server, we'll assert true, and then we'll make sure that we get the stuff out we expect. Yeah, so we should probably take this and call that the key, right? Const standard string key equals that. And then we will turn this around, right? Instead of setting, will it be expecting? So expect equal 101 for the response status code. And does this have that normalize it does. Oh, hold on. This was connection could have multiple things. So we had to do this, right? Actually, we already have the code here. Expect WebSocket. It's just we have to expect it in the response. And then expect equal this. And this is key. For the response header's get header of that. Get header value. Okay. Those are all the things, right? 1, 2, 3, 4. 1, 2, 3, 4. Okay. So this is going to fail, right? Because we don't do anything yet. Open as server. So it's going to need to check the things we set. The if request dot this stuff right here, right? Only it's from the request. It has to have upgrade as a connection token. It has to have the upgrade set to WebSocket. It has to have a key. And I think we can just, we don't have to verify that it's at base 64. We're just supposed to add the salt to it and then hash it. So, yes. We don't need to verify the version's 13 though. Is that done anywhere up here? No. Only the server really needs to check that. So if request.headers.get header value sec WebSocket version is not equal to currently supported WebSocket version, return false. Suppose we could do that first, right? And we can also say that the key has to be present. So if not request.headers.has header sec WebSocket key. Actually, a better thing to do would be to decode it, and it has to be 16 characters long, right? So if we'll get it first, const string key equals get header value. That. Now we'll say const auto. Well, this could be auto as well. Decoded key. Base 64 decode key. Well, basically, if that dot length is not equal to 16, maybe it's a strict requirement, but we're enforcing that the length has to be the, well, let's make this a constant. So required WebSocket key length const expr size t, that equals 16. This is the required length. I'm going to make sure it says required somewhere. It just says it is. It doesn't say it must be. We'll make it a requirement. This is the required length of the sec WebSocket key header. This is the required length of the base 64 decoding of the sec WebSocket key header in HTTP requests that initiate a WebSocket opening handshake. All right, so we'll do the opposite. Pretty much the same as what the client is doing, right? Not the same, but a lot of the same things. This will be returning true, by the way. We put in the response. Does it have version in the response? It's not. Okay, so we don't need to do the thing. We don't need to do this, but we put an accept in there. I guess we should do the upgrade first, right? Upgrade. Let's do, I think it's better to do the connection. Update the connection tokens to include upgrade first, and then you can say upgrade socket, and then set the accept to be, here's where we're going to use that compute key answer to the key. Do we want to store this in the impl? Is there any reason to? I don't know. Might as well, right? And then that's it, right? We're not doing sub-protocols yet. Let's build that and test it. Okay, status code isn't set. Status code 101 response.reason phrase. We should say the same thing. Technically not required, but it's just it would be rude not to set the reason phrase, I suppose. And let's have our test check that as well, even though it's not required, but the test is sort of documenting that it will do that. All right, cool. So that's it. We have a fully, oh, hold on. We don't, because I forgot to do a couple things. I forgot to store the connection. Actually, I forgot to do a lot of things. Before we, yeah, let's make a test for that since I was dumb. We can't just assume that it worked. We need to like try sending a ping or something. So we'll just repeat the same test. Which means I'll need to store the connection separate up here and pass it there. And then we're not going to call open. It should already be open at this point. Our test will fail because it's not set up right. So to fix it, right before we return, we're going to call our own open connection and the role of server. There we go. And then we'll need to do the same thing for client. So let's do the same thing. Hold on. I need the version that, yeah, that does the masking stuff. Complete open as client, right? So make the connection up here, pass it in here, and then do the same thing this one does, which is just send a ping. We don't really need this verification here, though. So, tell it to ping, we should see an encoded ping. So that would be 89 masked, and the length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Oh, I guess I had, constant or string data equals that. Data I. We don't have to do 6, we can do data.length. Actually, we can be a little bit smart here. We can say data length plus 6. 2 for the first part of the frame, and then 4 for the mask. All right, let's try that out. That should crash, of course, because for the same reasons before, we didn't actually open and store the connection object. So that's just a one-liner, though. It's finish open as client. So if everything works, then we open it with this client role. All right, cool. Let's check that in, because we're actually done with WebSockets, believe it or not. Oh, no, we're not. We didn't do protocol violations, but I'm going to leave that to the next stream, I think, because I need to wrap this up. Having some guests coming over, so going to wrap this up and finish up the stream. So implement open handshaking for both server and client roles. Let's go back and see if I forgot to check something in. Okay, we're all good. So this is all checked in. Run our unit tests. So make sure we're all in a good state, and then I'll wrap up the stream. I'll give a little summary what we did and chat about what we'll probably do next time. So yeah, we worked on a bunch of things today. I had this SHA-1 or SHA-1 hash function implementation from some previous work, and I brought it into GitHub, and I added unit tests from some standard test vectors I found online. I implemented the base64 algorithm, so that's its own separate project. And both of those, they're pretty simple. They're just two functions, and that's really just for convenience. So you can pass in the thing to hash as a string or a vector of uint8s. Base64 is similar, so you can encode and you can decode. So pretty simple stuff. Then we added strong entropy random number generator to system abstractions. That was a little bit more interesting. Let's look at that. Actually, I'm going to be looking at the Linux stuff too. So here's what it looks like in Windows. The header file was simply a you make an object called cryptorandom, and you call generate whenever you want some random numbers. For Windows, it uses bcrypt genrandom from the bcrypt Microsoft library. And for Unixy, it uses dev urandom and just reads from it. So that's pretty straightforward. We're not doing any cryptography. We're just kind of relying on other libraries to do it. So not exactly reinventing the wheel, but I don't get into crypto stuff mostly because I don't know it well enough to do a good job. So we used the remainder of the stream time to implement the open handshake functions. So that was all about these HTTP requests and responses. So both the client and the server have to play their role, right? The client has to set a key, and the server's got to respond by combining the key with some salt and hashing it and returning it back. And then both sides have to signal that they want to upgrade the connection. And the server has to say that it's switching protocols. So we handled all of that by adding some extra methods to our WebSocket class. So we had open before. We added start open as client. So that generates, or basically adds or augments a request to add all the things that are WebSocket specific to this request. And then we had finish up as client, or finish open as client, which checks the response to make sure it looks good. So it returns success if it looks good, false if not. And then on the server role, it's just one thing, open a server, because the server checks the request and generates the response. And then both the open a server and finish open as client are using the open function we had before, which goes directly into the open state and setting the role manually. And we're still exposing that through our public API because our tests are using that to kind of skip the handshake step since it's a bit involved. So we did all that. I didn't quite get to the last part is we need to catch protocol violations. So if you look in the code now, WebSocket.cpp, if you just look for the word to do, you'll see different places where we have unexpected things happen or protocol violations. I'll be reviewing the spec to make sure, but I think the correct behavior is for us to close the connection and return a special code that indicates there was a protocol violation. So we'll be doing that next time, I think. And then after that, we're going to start to try to use our WebSocket class. I want to make a plugin for our web server that represents a chat room. In order to test that, I'm going to need a web app to talk to it. Unless I can find a web app out there that I can change, I'll probably make something simple in the React framework and test it locally. And another thing I would need to do is get this web server running outside of my local setup here, like somewhere where my listeners can come in and play with it. So maybe that's another thing I'll try to set up before the next stream, or maybe 2 streams from now, is I'll try to set up my web server running somewhere publicly so that when we have this chat room, anyone who views the channel can kind of play around with that, try to break it, right? So that's what I think we'll set the goal to be next time. So I want to thank everybody who's been watching. Next time I'm streaming will be tomorrow, 9 p.m. Pacific. So what is that? A day and 5.5 hours from now. So yeah, thanks for watching. I hope it was interesting. And let's look and see right now if there's anyone we can host. Not that very many people are watching, but I'll leave you with something I find really fascinating. And this is a guy who is hitchhiking America, trying to hit all 50 states. So we're going to host him just to give you guys something interesting to jump to. And I hope to see you guys tomorrow. Take care.